All right, so we're going to go ahead and get started with chapter 6. And the question for today is, how many children are in your family? So hopefully you've gone through and worked out the questions on the first page, and you're looking at this after the fact. Okay, so each one of you should have counted up the number of children in your family, including yourself, and including all stepbrothers, stepsisters, half-brothers, or half-sisters, and you've put that number on the board. So the next thing we want to do is we want to go ahead and let X be the number of children that are in that family. Suppose we were to choose someone at random from the class. Let's find the probabilities for each of those. So this is just an example that I had to come up with since I don't know what you guys are going to get when you do this in class. Okay? So is this a valid probability model, and explain. So what makes something a valid probability model, remember, is that the probabilities are between 0 and 1, and that the sum of the probabilities is equal to 1. So this would be a valid probability model because each probability is between 0 and 1, and the sum of the probabilities is 1. Okay, the next question says, is 5.7167 a possible value for X, and explain. And so I would hope that you guys said no, because you can't have a part of a child. For this reason, this particular variable, the number of children in a family, is a type of variable that we call a discrete variable. Okay? Now, question 3 asks us to make a histogram to display the information with X on the horizontal axis and describe the shape. So, in this case, X is the number of children in the family. So, when I make my graph, these values here at the bottom are going to be the number of children. And so in this case, we have 1, 2, 3, 4, 5, 6, and more. Right? So 1, 2, 3, 4, 5, 6, and 7. And I need probabilities that go up to 0.3. So 0.1, 0.2, 0.3. These are probabilities. Okay, you could leave them as fractions. You can change them into decimals. I think it's just easier for these to change them into decimals, so that's what I did. So my histogram would look something like this. And then thinking about the shape of this histogram, I would say it's probably slightly skewed left, and it has one peak, in this case at 4. Okay, now of course yours is going to look differently. Remember that if it's skewed to the left, it's because you have a tail that's to the left hand side, right? It's like your left foot. If it's skewed to the right, then it would look like your right foot, where you have the tail off on the right hand side. Okay, and if it's symmetric or roughly symmetric, it's about the same on both sides. Okay, now number 4 says, describe in words what the probability of X greater than or equal to 3 means, and then find the probability that X is greater than or equal to 3. So in words, this means the probability that a randomly selected student has 3 or more children in their family And this would be, the probability is, let's see, 3 or more, would be 7 out of 10, or 0.7, 70%. 5 says, describe in words what probability x greater than 3 is, and then find the probability that x is greater than 3. So here, oops, that would be the probability that a randomly selected student has more than 3 children in their family. And that probability would be, let's see, more than 3 would be 3, 4, 5 out of 10, or 1/2, 0.5, 50%, however you'd like to describe that. Now, we need to find the average of the x values. So the average of the x values would just be adding all of them together and dividing by 6, right? Which should give us 3.5. Does this value tell us the average number of children in the families of students in this class? If yes, explain, and if no, why not? So in this case, do all of these values have the same chance of occurring? And the answer is no. So in this case, it would be important for us to use what we call a weighted average. Okay, so let's see. We're going to say no. Because some values have a larger impact on the mean because they occur more often. And so here, what we need is a weighted average. And so essentially a weighted average is like how we calculate your GPA, or not your GPA, I'm sorry. Well, yeah, your GPA and your average in most classes. Like in our class, for example, your tests are 45% of your grade, so they count more than your quizzes or your homeworks. So you have to take that into account when taking the average. So in this case, you would do something like 1 times 1/10, 2 times 2/10, 3 times 2/10, 4 times 3/10, 5 times 1/10, and 6 times 1/10. And that would give us the weighted average. So essentially what we're doing is the mean of x should be the sum of each x value times the probability of that x value. All right, and this is our weighted average here, okay? So let's take a look at our important ideas, or our big ideas. So first thing is that we need to understand what a discrete random variable is. So discrete random variable. And so a discrete random variable takes a fixed set of possible values with gaps in between the values. Okay. The other thing that we could have is what's called a continuous random variable. And so we didn't see an example of that today, but we should probably see one tomorrow. So a continuous random variable can take on, any value in an interval. Okay, so for example, the weight of a baby can be anything in the given interval from, let's say, 0 pounds to 11 pounds, meaning it could include ounces, it could include pieces of the pounds. Okay, it's not just a set number. Okay, then the other thing we did was we looked at the histogram that displayed this discrete random variable. And so what we had was the values of your variable down here, and then the probabilities up here on the side. So the probabilities, of course, should range from 0 to 1, as always. And then you would have your little bars that represent the probability of each of those values. Okay? And then finally, the mean or expected value for one of these discrete random variables. So mean of x, as I wrote on the other page, should be the sum of xi times pi. So each x value times its probability. Okay? So here, I would suggest pausing the video for a couple minutes and working on the check your understanding questions, and then coming back and checking your work using the video. Okay? So go ahead and pause it and come back in a couple minutes and check out the answers to these questions. All right, hopefully you've taken some time to work on answering these questions, and we'll use this to go over it. So it says, Indiana University Bloomington posts the grade distributions for its courses online. Suppose we choose a student at random from a recent semester of this university's business statistics course. The student's grade on a 4-point scale with A equals 4 is a random variable x with this probability distribution. So you have the value of x here on the top, and then the probability of each of those x values. Number 1 says, write the event the student got a C using probability notation, then find its probability. So a C, if this is A, right, we're going down, and you have your C there in the middle. So this would be the probability that x is equal to 2. Now, of course, because this is a probability distribution, all of these probabilities should add up to 1. So this should be 1 minus the sum of those probabilities. Whoops. Okay, and so when I add all of that and subtract, I should get the probability. And this gives me 0.138 if I'm not mistaken. Okay, 2 says explain in words what the probability of x greater than or equal to 3 means, and then what's the probability. So this is the probability that a randomly selected student gets a B or better, and this probability is 0.819. Okay. 3 says make a histogram of the probability distribution and describe its shape. So for my histogram, I know I need here on the bottom, this is the grade. So 0, 1, 2, 3, 4. And the only reason I'm going up to 5 is because I'm doing these from 0 to 1, 1 to 2. I could also center them around the value. You know what? Let's try that on this one. Let's center them around the value. So we'll do this a little differently than we did the last one. Okay, so I have 0, 1, 2, 3, and 4. And for my probabilities, I need to go up to about 0.5. So I'm going to do that here. And these are my probabilities. So 0 is a really small little chunk. 1 is another really small little chunk. 2 is going to go up just past the 1. 3 is going to go up about halfway between the 3 and the 4. And then 4 is going to go up about halfway between the 4 and the 5. All right, so this probability distribution is definitely skewed left with one peak at 4. So that means most students, or the highest probability of a grade a student would get, is a 4 or an A, okay? And then 4 says calculate and interpret the expected value of x. So the expected value should be 0 times 0.011 plus 1 times 0.032 plus 2 times 0.138 plus 3 times 0.362 and then plus 4 times 0.457. And so this gives me a value of 3.222. So what is this telling me? This is telling me if many students are chosen at random, the average grade is about 3.222. Okay? So hopefully you were able to work through these questions without too much trouble. You have some stuff to work on for homework tonight, and then tomorrow I can answer any questions and try to help you with any misconceptions or any issues you're having. All right? I hope you have a great day. Thanks.